All right, we have done a whole lot of factoring. Hopefully you've done lots and lots of practice of that. Now I just wanted to spend a couple of slides talking about applications of factoring and of what good they are. These will just be a couple, and there's lots more coming in future sessions, plus in future courses. But this will give you a flavor for what kind of things we can do with factoring. So what we want to do is solve quadratic and polynomial equations using factoring, and then maybe an applied problem that might involve that too. So far we have worked only with polynomial expressions, specifically quadratic expressions. And here's an example of an expression. Okay, there's no equal sign, we've just manipulated this. But now what we want to do is just add an equal sign and some number on the other side here to allow us to look at this equation and solve it for x. So in other words, what values of x will make this equation true? Similarly to if I had 2x minus 4 equals 8 and I wanted to solve that, I'm looking for the value of x that would solve that equation. In this case, I'd move the 4 to the other side and add it, and then I'd divide both sides by 2 to come up with 6. So 6 is the value of x that makes this equation true. So here we want to do the same thing. We want to find the values of x that will make this equation true. Well, not unfortunately, but when I have a quadratic equation like this one, I cannot do the same kind of tools or solve it the same way I did just a linear equation. Here I added both sides, divided both sides, I was done. In this case, I can't move the 18 over to the other side. Well, I guess I could, but it doesn't do me any good. The trick or the tool that we use in order to solve quadratic equations is, yes, you guessed it, factoring. So what we're going to do is factor, and then we'll use another rule that helps us figure out what the x's are. Okay, and here's what that other rule is. The rule is called the zero property. And the zero property states that if a product of two factors is equal to 0, one of these things got to be equal to 0. So if I have x times y is equal to 0, there's no way I could have something like a half times a quarter that's not going to be equal to 0. Either x or y or both have to equal 0. So one of them is 0. So what we do is we use that property when we factor this equation. So there's a squared there. So if I have x squared plus 3x minus 18, if I factor that using one of the tools that we've done before, so x squared, so that's an x and an x, two numbers that multiply to a negative 18, I'm calling a positive 6 and a negative 3, and add to a positive 3. Yeah, I think that works. You can FOIL it out to check it. At any rate, I factor this quadratic expression on this side. It's part of an equation, but I just take this little piece to it and I factor it. Now, since it's equal to 0, and this is a critical piece, thou shalt make it equal to 0. That's one of the commandments here. Since it's equal to 0, I can use the zero property, which says that if I have two things that multiply together to give you 0, one of them's got to be 0. So in this case, I'm going to say x minus 3 is equal to 0, or x plus 6 is equal to 0. And this is according to the zero property. That's what the zero property says. Now I've got two little linear equations, now I can solve them. So x is equal to 3, or x is equal to negative 6. If you'd like, you can take, and it's always a good idea, plug that 3 back in. 3 squared. Let me move this down just a little bit. Move this guy down a little bit. And let's just check that. So 3 squared plus 3 times 3 minus 18, is that equal to 0? I wonder. 3 squared is 9. 3 times 3 is another 9. minus 18. Yeah, that'll give you 0. So x equaling 3 checks. Let's check the minus 6. That looks a little dicier. Okay, minus 6 squared plus 3 times minus 6 minus 18. I'm wondering if that's equal to 0. Here's my check. Minus 6 squared is 36. 3 times minus 6 is minus 18. Yeah, it's going to work. 36 minus 18 is 18. 18 minus 18 is equal to 0. Good. So they both check out. So, solving a quadratic equation, I make it equal to 0, critical piece, factor this side, then use the 0 property, one of my favorite properties, and solve each of the linear equations that results. Let's try it with this guy down here. Right now it's not looking too good because it's not equal to 0. I gotta make it equal to 0. Let's make these two guys go over to the other side. So I'll call it 2y squared, it'll be positive, plus 5y, bring the 3 over, it'll be a minus 3, and I'm left with on the right side of 0. Critical piece, has to be 0. I cannot use the 0 property with anything other than 0, I guess, which makes sense. Okay, now I factor this. I'm just going to use the guess and check, or they call it the FOIL method. We use guess and check. So 2y squared would break up to 2y and y, and then 3 breaks up to 3 and 1. I think I'm going to put the 3 here and the 1 there. It's a positive size 5, so this would be positive and this would be negative, I think. 2y squared plus 6y minus a y, yeah, that'll give me that. Minus 1 times 3 minus 3. Yep, good. Factored out. Always good to check those. And if you wanted to factor this using the AC method, have at it doing it that way too. Okay, now I've factored this. I've got two factors that the product of those two is equal to 0. Well, one of these has got to be 0. So I say 2y minus 1 is equal to 0, or y plus 3 is equal to 0. Okay, that's according to our 0 property. Solve this, so the 1 goes over, divide both sides by 2. I get a half for this side. Take the 3 over to the other side, it becomes negative. Therefore, my solutions are a positive 1/2 and a negative 3. If I want, I can take those and plug them back in just to confirm that I've done it correctly. Okay, so the 0 property, powerful tool when I'm solving quadratic equations. Just going back here, so here's a quadratic equation. To solve that, I have to factor. Here's a linear equation. To solve that, I have to isolate the x, so move the 4 to the other side, then divide both sides by 2. That's how I would solve a linear equation. A quadratic equation, I solve it by factoring, like I did here. Okay, another application, I guess, of using factoring is if I'm looking for the domain of rational functions. We'll look at rational functions here in the next module, I think. But rational functions mean fractions, typically. Well, they can be whole numbers too, but typically rational, your eyes start going funny because you're going to get fractions there. So when they say the domain of a rational function, they're asking for all the possible values of x. We saw that in a module back. So any possible values of x. And we saw that if I have a 0 on the bottom, then that limits my domain. It also limits the range. Okay, so there's numbers that are not allowed to work in that particular function. So in this case here, what I'm looking for is I'm looking for all the values of x that are allowed. I know that I can't have 0 on the bottom, so I've got to find out some way of figuring out what values of x will make this bottom thing 0. And so what I do is I say x squared minus 3x minus 28 cannot be equal to 0. And then I solve that. I guess this is an inequality, but I'm solving it the exact same way that I would solve just a regular equation. Okay, so let's factor this. I'm looking for two numbers that multiply to 28 and add to 3. 7 and 4, That's what I'm thinking. X, X, X. I'll put a -7 here and a +4 there. I picked the -7 because the larger number is negative because this middle number turns out to be negative. So that's why I gave the larger number a negative. If you FOIL that, that'll come out. Okay, so the product of these two things cannot be equal to 0. Using the 0 property, I would say x plus 4 cannot equal to 0, or x minus 7 cannot equal to 0. So in this one, if I move the 4 over to the other side, x cannot be equal to -4, nor can x be equal to a +7. Okay, so here, if they're asking me for the domain, okay, what are all the possible x values that'll work here? I would be saying you can use all the x's you want as long as you stay away from a -4 and a +7. Because if you plug those two numbers in, or this one or that one, into this here, I'm going to get 0 on the bottom. That's not allowed in a real number function. Therefore, you can't have them. So -4 and 7, I can use all the other real numbers, but not those two. Okay, one last application of using quadratic equations and using factoring to solve them. I've got an envelope here, and the question says that my envelope is 4 centimeters longer than it is wide. So if my width is W, then my length, this is my length here, rather than using an L, I'm going to say my length is whatever the width is, plus another 4 onto it. So the width is W, the length is W plus 4. But then the question says that the area is 96. Well, I know the formula for the area of any rectangle is length times width. So I know the area is 96 equals the length is W plus 4 and the width is W. Oh, now what? Well, maybe I could use a distributive property here. Let's try that. W times W, W squared. W times 4 is a plus 4W. Oh, I'm seeing quadratic stuff here happen. If I have a quadratic, I can't solve it like this. Thou shalt make it equal to 0. So let's move this 96 over to this side. So I get a 0 is equal to W squared plus 4W minus 96. That's looking good. Okay, so now I have a quadratic. It's equal to 0. So I can go 0 is equal to and do my two brackets here. So I'll have a W and a W. Two things that multiply to 96 and add to 4. Oh, great. Let's see. Oh, great. 16 times 6, that's 96, but the difference there is 10. How about 12? 12 times 8, is that right? 8 times 2 is 16 plus 1, that's 9. Yeah, that's right. Oh, and there's a difference of 4 there. Aha, got it. So I have to put a 12 here and an 8 there. This is positive, so the bigger number is positive, and this one's negative. There, perfect. Okay, so now I can use the 0 property because I made it equal to 0. So I'd say W plus 12 is equal to 0, or W minus 8 is equal to 0. Here, W is equal to a minus 12, or W is equal to a positive 8. Now, when I look at the question, I'm talking about a rectangle or an envelope. So when I look at my two answers, one's a -12, one's a positive 8. Well, a -12, you can't get a width being a negative. Like distances are always positive. So I'm going with my width being 8, and so my length will be whatever the width is plus 4. So the width or the length is going to be 12. Just checking, I can see the difference of those two is 4, like the question said. And if you multiply 12 by 8, like I did here, you do get 96. So it's a nice application of using quadratic functions. There's lots of other ones that are coming up, and we will look at those on another day. Try some questions, give me a call.